Okay, do you guys want to start? Yeah, okay.
Add a skill.
I have this one.
Yeah, I can use people actually.
Okay. And you can just like go up to my laptop and then.
So I the slide could just pulled up on your laptop.
Yeah, that's fine. I just pulled up my own laptop. You can just like
Okay.
press.
Yeah. Sounds good. Let's see. Here, let me actually. Small session.
Small set.
That's okay.
Sit anyway.
Thanks. Just not starting interviewing before the students. People are probably starting independently in groups, right? Zoom. Fortunately, Zoom. Like the in-person. All right, can everyone hear me okay? Yeah, so everyone, welcome to the second review session for your final. So this one will cover everything that's post midterm 2, so that involves scheme and SQL. So I'll be covering the scheme portion of the review session. So we'll kind of just start off with a little mini lecture about some of the topics in scheme and review some of the stuff that you guys might have forgotten because it's been a little bit of time since you covered this. So just with a little bit of an overview. So the big thing about scheme is that it's a functional programming language that is it consists of expressions, which means that everything is kind of evaluated. So any sort of expression that you pass into scheme, it's evaluating it to some sort of final value. And there is kind of breaks up into two different types of expressions. So there's atomic expressions or primitives, which just evaluate to themselves. So Booleans, numbers, things like that, very simple stuff that is able to just evaluate to itself very simply. And then finally, you have all of your functions and addition, subtraction, the functions that you defined and things like that, which all once again evaluate to a final value, which is what scheme is dependent on. So again, you have call expressions and special forms. So special forms is how you kind of have control in scheme with defining functions as well as if statements. And again, like if statements, just even though they are controlled, they still all evaluate to something as well. So is there any questions on kind of the overview of scheme that you have, or anything like that? I can before I move on to the next slide. All right, if not, then we'll go a little bit into more detail about what scheme kind of entails. So the scheme is very much, you want to kind of, I see it more like a Russian doll kind of, where you want to evaluate from in out. So you want to look at the smallest expressions within each kind of expression, and then evaluate those, and then you pass in those the evaluated form into the bigger expression until eventually you get to the big expression, and you evaluated everything inside, and then it finally returns some large value. So one thing is that if it's not in a special form, then you want to evaluate the operands and then apply the operator to the operands. So what this means is, like, if you're calling a function on, you're adding some number to a value and then passing that in as a parameter to a function, you want to make sure that you actually evaluate those parameters before you pass it into the final function and then evaluate the entire thing. So this one's a little bit tricky in word form. I think it's a little bit easier to see with an example. So we'll kind of get to those a little bit later with some of the problems that we have. So another big thing to keep in mind as well is that you guys might have seen this if you've done the homework, is that Scheme doesn't really have any sort of iteration. So it's entirely dependent on recursion if you want to iterate through anything. So the big thing about Scheme is figuring out how exactly you can set up your base cases and your recursive cases and all of that in order to kind of iterate through anything, whether that be a list or, stepping from a number to a certain number or something like that, Any questions about this slide and what I covered so far? If not, then I'll move on to the next portion. So this is what we talk about when we mean special forms. So there's really mainly three special forms that are most commonly used. So you have if. So in if if you look at the format here, you have if and then some sort of predicate. This has to evaluate to some sort of Boolean. And then you have your expression that it'll return or evaluate to actually if the predicate is true. And then finally, you have your expression that evaluates if it's false. So when you run this, it'll actually check the predicate and then it'll evaluate to this first expression if it's true, and then the other expression if it's false. So again, everything about Scheme is evaluating towards something. And then you kind of have the little bit of an expanded form version of if with cond. So this one you can actually is very useful when you have multiple conditions, right? In the case of Python, you have your if, elif, and then else. So this one allows you to have multiple different predicates, and then it'll step through the predicates sequentially until eventually one of them hits, and then it'll evaluate to the expression that it's associated with. Otherwise, it just has that else edge case to evaluate to. So finally, you have this one's a little bit different than the ones above. You have your define. So define is how you set up all your functions in Scheme. So one of the biggest things about Scheme is that you can actually just when you actually run define, you're setting up the function as if you were to as if you were to call it, kind of. So if you look at the formatting, right, you're defining the name and then you just write your parameters out separated by spaces as if you were to call the function itself. And then you add your body, which is what that function will evaluate to when you call it. So this one's a little bit trickier in the sense that define still does evaluate to something. It evaluates to the actual name of the function, but there's also, you have to keep that separate from lambda expressions, which just returns a function without any sort of name. So do you have any questions about these special forms? I know these ones are a little bit tricky and there's kind of a lot of technicalities that you have to keep in mind as well. All right. If not, then we can move on to the next portion, which is a little bit more common special forms. So again, these ones, you probably have seen them in Python and you know them relatively well. You have and, or, so and behaves very similarly to Python. Anything that is pretty much like not, you have falsy and truthy values, right? And then that and expression evaluates to until it eventually reaches a false value, and then it returns that false value, or it returns the last expression if all of them are truthy values. And then you also have your or statement as well. In that case, it's kind of the inverse, in which it'll evaluate each expression until it reaches a truthy expression, and then it returns that first truthy expression. And if not, then it just returns the last expression. So this one's a little bit kind of like following the logic of Python. So do you guys have any questions about like how and or evaluates in Scheme? If not, then we can kind of move on to let. So let is a little bit tricky. This one actually kind of takes advantage of scope in Scheme, which we don't really see very often. So let actually, you have your essentially a scheme list of bindings, and those bindings are essentially variables that are only defined within the scope of that let expression. So if you have, you'll see a little bit more of this in the problems, and I think it'll make a little bit more sense then. But what let actually does is it assigns specific values to keys within that scope. And if you try to evaluate any of those certain keys outside of the let expression scope, it'll actually throw an error because it's not going to know what those are. This one's again kind of a little bit difficult to follow compared to the rest of the stuff in Scheme. So do you have any questions about that? If not, then finally we have begin. So begin is kind of how you can evaluate multiple expressions at once instead of just having it evaluate to a single value. Because normally what happens in Scheme is that you used to have a single expression, and then it keeps evaluating expressions inside and passing it into more operators until eventually you just return one value or a list or whatever that may be. And begin is how you're able to evaluate multiple expressions at once. So this one, you can just pass in multiple different operator calls or things like that. And then it just evaluates them sequentially and then returns all of those values together. It just returns them by a list, line by line. So if there's no questions on that, finally you have append as well. So append is very different than Python's append. So Python's append will actually mutate the original array that you're calling it on and then add whatever value that you're passing in. So that one's very much mutative, whereas opposed to Scheme, it returns a whole new list. It returns a copy of a new list in which you just paste the two lists together, just binds them together. And this is very much different than Python because you're supposed to pass in two lists and then it just kind of adds them together, which is a little bit tricky because in Python that's normally denoted by the plus or the extend as opposed to append, whereas Scheme just uses append for both of these. Any questions about any of these special forms before I move on? Yeah, go ahead.
Yeah, sure. Let's still a little bit confusing to me, like all the other ones make sense.
Yeah.
Because begin is like evaluates these expression order, so you have multiple expressions, but it seems like the binding part's so confusing.
Yeah.
How does that work?
So let's kind of how you like establish scope within Scheme. So it's a little bit tricky to see with this formatting that they have here, but what actually kind of happens is hard to see. But what happens is you'll see. I think you'll see it in the problems as well. But there's actually parentheses in that. Within those parentheses, you have like these bindings to like you can have like a big parenthesis and then X is binded to 0 and then B is binded to 1 and then A is it's a little bit tricky, right? But then you can use those values in the body and then it'll evaluate whatever that body is using the values that you just assigned.
So it's almost like a pair.
Yeah. Yeah,
thing.
kind of, yeah.
Okay.
So that's how you kind of like assign a bunch of variables to specific values within that scope and then make sure that is encapsulated within that. I think that it's kind of
not as tight as like, because you could just define an expression or variable, but like that's like a way of defining it.
Yeah, it is a way of defining it within a scope. Yeah.
Okay.
Yeah. All right. So, any more questions about more common special forms? All right. If not, then we can move on to the next portion. So this is kind of another big thing in Scheme is schemeless. You're likely to see like some sort of schemeless problem on your exam. So schemeless are very much like Python linked lists in which you can access like the first element of a list as well as the rest of the list, which is just also a linked list as well. So instead of having link.first or link.rest like you have in Python, you have car and cutter. So car just returns the first value, it's an actual value, whereas cutter returns another list, which is everything but that first element. So this one you just have to make sure to keep in mind it's not like Python list because everything in Scheme is a linked list. So you definitely want to make sure that you don't make any mistakes with that, like kind of assuming that it works the same way as Python lists. So that's how you access values. In terms of constructing a list, there's three main ways to do this. So one of them is using the cons operator. So this this one is kind of like the way that you assigned link within, or you created links using the link object within Python. So so that one you'd have link, right? And then you pass in the value that you want to have as your first. And then the second parameter that you pass in is another, either nil in that case where the list is ended, or it's just another link, right? So in this case, you're just replacing link with cons. So you have cons, you pass in the first element, and then you can have another cons and then pass in another element and then have nil. In that case, it'll take a 2-element array. So it's a little bit difficult to show this without kind of drawing it out, but again, you'll see it in the problems as well, how you're able to use cons, especially recursively. This is very useful recursively to construct linked lists. And then the second way, this one's a little bit simpler and a little bit like less recursive. So this one you have just use the list operator, and then the list operator just use pass in any amount of elements, n amount of elements separated by spaces until you're eventually finished with the list, and then it just evaluates to the list with all of those elements. And also, again, everything that you pass into these are always evaluated before they're evaluated to their final form before they're actually passed in. Finally, we use this is using quoting. So quoting will actually it's very much like this is what they call like a string literal form, where it literally will just create a list of each element. You use parentheses because Python uses brackets, but Scheme uses parentheses to signify lists. And in this case, it's pretty much the same thing as using the list function, but it doesn't actually evaluate any of the elements within the list because it takes it very literally. Everything that you pass in, it's just gonna return that as a literal object. And then you can, do things like evaluate that. You guys kind of saw a little bit with the Scheme project where and also some of the homeworks where you worry about evaluation and things like that. But this one's very useful if you just want to actually have the program data as well in the list. So any final questions about how Scheme handles lists, as well as how you can construct them? And you'll see there's definitely a lot of creative things that you can do with recursion using Scheme lists. All right, if not, we can move on to the next portion. So again, yeah, this is kind of a good way to see the comparisons between Scheme lists and Python lists. So this one, right, you can see you have link, and then every other second parameter, right, that you're passing in has to be another link, or it's null, or link.empty in that case. So in this case, you have cons followed by 1, which is the first element, and then you have a second cons that's passed in as well. So all of these are very much very similar to Python, which is good because you guys kind of worked with that for a while. Same thing with car, as I mentioned before, equivalent to a.first, and then cutter just returns the rest of the linked lists. You also have a little bit of a I don't know, these are more like a little bit weird ways to kind of get specific values in linked list. You have catter, which is just, you can kind of think of that as car and then cutter, so it's getting the second element in that list. And then you have the couple with the cutter with the double D, and in that case you're getting the the rest of the linked list besides the first two elements. So this one you have to be a little bit careful with, because if you do call these on, in this case, if you call it on the last element, if you call both of these on the last element of a linked list or a scheme list, it'll actually error out, because you can't call cutter on a link.empty and you can't call car on a link.empty either. And then you also have this diagram as well. Again, very reminiscent of what Python has. All right, so we will move on to some of the practice questions now. Once again, any final questions about Scheme? Anything at all? Yeah, go ahead.
Just one question about the list.
Yeah.
Versus con construction.
Yeah.
Like the cons is great for recursion.
Yeah.
You use the list for recursion, and what's the usefulness of having lists for some cons?
Yeah.
I see cons more often.
Yeah, so you're right. Cons is very much useful for recursion, because if you're trying to like construct a list, right? And you're iterating to another list, you can just do cons of like the first element and then like do a recursive call to the other element, right? List is more useful when you're just trying to like quickly construct some list, right? So let's say I had a problem where it was like, I want to return a new list where each element, instead of being like, it's just a bunch of elements of numbers, right? Each element is a list with its index followed by its number as well. So pretty much when that happens, right, it's very easy to just use list and then pass in the index as opposed to, and then followed by the element as well. So it's just very easy for quickly constructing a list as well. Yeah. So why exactly we're using begin, since the code runs the sequence by itself? That's a good question. So the reason that we actually, let me go back to the slide real quick. So the reason that we use begin is because Scheme oftentimes just evaluates a single expression. So in the case of like, when we define a function and then we might call that function with specific parameters passed in, it'll just evaluate to a single value, right? But when we want to evaluate multiple things, that's when we want to use begin. So in the case of like, we want to evaluate this expression followed by this expression, followed by, any amount of expressions that we want, it's very different. You can't do that in Scheme without using begin. So that's really what's begin's useful for. Does that answer your question?
All
right,
that was
yeah.
their question.
Oh yeah, on the chat. Sorry about that. Yeah. All right. Any final questions? You can put them up in the chat. If not, then we'll move on to some of the Scheme practice as well. So I'll be handing it off to someone else for this one. So
Yeah, so now we'll just be going over a couple Scheme problems from past finals or midterms. So the first one we're going over is just from last spring. It's called Bedazzled. And in this problem, what we're essentially doing is we're implementing a Scheme procedure, which takes in a Scheme list that has like a bunch of beads, and it takes in a given length, and then it should return a list that creates a necklace with these beads of the given length. So in this first doc test here, we see the beads that we entered are like this curly hyphen and a star, and we want the length of the return list to be 3. So we just have like a curly and then a star and then another curly, and the length is now 3. So we just return that list. Are there any questions about what the problem is asking for? Okay. If not, then go ahead and take maybe like 5-10 minutes to try and do the problem on your own. And for those of you in person, feel free to like talk to each other, and then we can come back and go through it together.
Is B supposed to be like indented? Is the if statement in column, is B supposed to be indented, or is it already assumed?
It's okay where it is in this case.
Oh, right, this is scheme.
Yeah.
Yes, yes.
Okay, so I know that was maybe not enough time, but does anyone have any ideas for how we could go about solving this problem? Go ahead.
So maybe you can have like a base case when the length is, when the length is one,
Mhm.
and then you can take the car of that,
Mhm.
and then for the rest you recurse on like the car, and then you subtract, or you take the cut of the D's and you subtract the length by one.
Yeah, so this is very close to the solution. Does someone back there have? Okay. Yeah, so you're really, really close. And a base case for length one, I think would work, but for the solution that we have here, they actually like made the base case where the length is 0. And in general, it's like a good idea to have your base case be like the easiest possible case, which in this case would be if length is 0. So yeah, so if length is 0, then what would we want to return? So if length is 0, we would just want to return nil, right? Because we want the length to be 0, so we basically want to just return an empty list. And then we know that everything in scheme happens recursively, and so the next blank we go into kind of goes into the recursive case. So what you said earlier about consing on the car of the list to the recursive call was like very, very close to the solution. So we do want to cons on the car of the beads, and then we want to have our recursive call, right? But in the recursive call, we don't just want to, so in our recursive call, we need a beads and length, right? And we definitely want to decrement length by 0. But for the beads list itself, we can't just call cutter of beads, because in that case, if our beads length, if the length of our entered beads array was like 3, but we wanted the list of our entire necklace to be 9, then we would actually not be able to like go beyond 3 beads, right? So we want to move on to the next element in our beads, but push our first element of the beads to the end. And so to do that, we can use the append method. So we can append the cutter of beads to the first element of beads. Does this make sense to everyone? Okay. And then this would be our new beads list. It's just the rest of the beads and then the first element of beads added at the end. And then we just want to decrement length by 1 so that we eventually reach the base case and return. And so this is the completed procedure. Are there any questions about this? Yeah, bar is supposed to be car. Why are we calling on nil? So as you mean here in the if statement, so this is our base case, right? So in the base case, we're just checking if the length is 0. And if the length is 0, then we want to return an empty list. And so returning this nil is our way of returning an empty list. And so that's why we have the nil there. Does that answer your question? Oh my God. How did you like go back in the slides?
She just used arrows, like the arrow keys.
Oh wait, well, sorry. So
Oh, we're
for
talking about like back to like the screen. Just add.
thank you. Yeah, so for D, why not cons, cutter beads, car beads? That's a good question. Yeah, exactly. So the second element that's passed in should be a cons itself. But in this case, it wouldn't be, it would be a bead. And so we would actually get an error. Oh, so why are we using nil in brackets instead of just the nil keyword? That is a good question.
It should just be no.
Oh, okay. It should just be no without parentheses. Okay, great. Thank you. Are there any other questions? Okay. Great. So if there's no other questions, we can move on to the next problem. Okay. Oh. I'm so sorry. How do you go back to full screen?
Wait.
Is it just here?
Or it's in here. I think. Wait, did app not work?
I don't think so.
Try refreshing the page and then okay, then present.
Oh, yeah. Beautiful. Thank you so much. Yeah, so the next problem we're going to go over is from 2018. And this description here is a little bit confusing, but it will make more sense when we actually see a couple doc tests. But essentially what this question is asking us to do is write a screen procedure that takes in a list of integers and it returns a list of lists. And these new lists contain the elements of the original list in the same order, but just split into lists which are non-decreasing. So in this doc test up here, this is like our inputted list, and then we return a list of lists, and each list within this list of lists just has non-decreasing integers. So we have 3, 4, 7, and then 6 would be less than 7, and so we add it into a new list, which is 6, 6, 8, and then 1 would have been less than 8. So then we have a new list, which is 1, 2, 5, 5, and then 4 at the end. And they kind of also give us like this helper method here, which you do have to fill in. And what this helper function should do is it should return the first run in a list and then the rest of the list. So for this first doc test here, if we enter 4, 5, 1, 3, 2, then the first non-decreasing run in this list is a list having 4, 5, right? Because 1 would be less than 5. So in this case, we want to return 4, 5, and then the rest of our return pair should be 1, 3, 2. So are there any questions about this problem? Okay, if not, then maybe take like 5, 10 minutes to go over it. I would recommend first writing in the next run procedure and then tackling the runs procedure. Okay. Yeah, and then just as a reminder, the next run procedure should return a pair, and the first of the pair should be the first run in the list, and the rest of the pair should be the rest of the list. So take like 7 minutes to try and do that, and then we can go over it together. but is anyone on?
If something with, it's just returning nothing or returning, it's like the end of the line essentially.
Right, yeah. Yeah, so that's very good intuition and it's basically correct. So we actually want to check if we want to check for some base case. And we're basically in our base cases trying to figure out if we have found a first run, right? And there's two ways that we know for sure that we found the first run in the list. And that's if the rest of the list is empty or if the car of the rest of the list is less than the car of the list itself. Because then we know that the next element is less than the first element. And so we know that the first element is just the first run. And so we just check for both of those things. And if either of these is true, then we know that the first run in this list is just the car of the list. So in that case, we want to return a pair where the first is just the car of this list and the rest is the cutter of the list. So does this make sense to everyone? Are there any questions about it? Okay, if not, then we can move on to sort of our recursive case. So if neither of these are true, then we go into this begin statement. And in this begin statement, we're setting this pair P to be next one called on the rest of S. So if you look at this first doc test here, we know that the cutter of S is 5132, right? And so next one called on 5132 should give us a pair where the first would just be 5 and the rest would be 132 because 5 is the first run in the cutter of S. Does that make sense to everyone? So once we have this pair where the first is 5 and the rest is 132, all we want to do is figure out how we can combine this pair with the first of this list, which is 4, right? And then return the first of this pair combined with 4 and the rest of the pair. And so to do that, we can just return a pair where the first is the car of S const on to the first of this pair P, and then the rest should just be the rest of the pair P. Does that make sense to everyone?
You can use first and rest.
Yeah. Because again, like in this first doc test, calling next one on 5132, it would give us a pair where the first is 5, right? And the rest would be 132. And then in this const statement, we're just combining the 5 with the 4 and returning 132 as the rest of the pair. Does that make sense? Oh, so this is a really good question. Why list car S instead of just car of S? That's because the problem is just asking us to return a pair where the first one is returned as a list. So even though in this case specifically, the list would only have one element, we still want to return it as a list instead of just like the car. Does that answer your question? Great, really good question. Are there any other questions so far? If not, then we can move on to this runs procedure. And so the runs procedure has a base case first, and this is exactly the base case that you had pointed out, right? Where if the list is null, then we just want to return nil. And then we go into this let statement. And in the let, we're setting this pair P to be next one called on this list S. And so recall that next one called on the list S is going to give us a pair where the first of the pair is the first run in the list S, and then the rest of the pair will just be everything in the list S after the first pair. So for this first doc test up here, the first of pair P would be a list containing 3, 4, 7, and then the rest of the pair would be 6, 6, 8, 1, 2, 5, 5, 4. And so now we want to figure out how we can use this pair to generate all of the runs instead of just having this first one. And the way that we could do that is by counting on the first of the pair to this recursive call on the rest of the pair. So again, in this case specifically, first of P would be 347. And we const that on to runs called on 66812554. And then that would give us all of the non-decreasing lists for this cutter of the list or the rest of the list. Are there any questions about this problem so far? Or I guess overall? This is a really hard problem. So no worries if it takes time to like sink in. Okay, if any questions come up, then feel free to put them in the chat and I can respond. But if not, then we can move on to like the SQL portion of the review session.
Can you circle back just?
Yeah.
2 seconds?
Yeah.
The second line on the left side.
This one?
That's first P runs rest P.
Mhm.
Right, because that's the recursion.
Yeah.
Yeah, okay. Didn't-
Yeah, so the rest of the P is like everything in the list after the first pair, and we're just recursively calling the runs procedure on that.
Right, you don't need to recurse on the first. It's first,
Yeah, so the first is the first run.
right.
Yeah.
First run, so it does not be one, it's like 2 or 3 elements.
Yeah,
I didn't know if it's 2, 3, or 4 elements or more. The first run, it's already predetermined, it looks like, right?
yeah. So we're getting this first one by using the next run method, which we've implemented here, right? And this one like also does its own like recursion thing, to like figure out the first run in the list. Does that make sense?
Yeah, that makes sense.
I guess you wouldn't know the exact size of the first one until like you fully run the procedure and see the output. But really good question. Are there any other questions? If not, we can move on.
All right, so the next part of our section is about SQL. And in sum, SQL is declarative, so it's essentially describing what we want to do, what we want to see in the results. So this is important. Its applications mainly are with databases. So it's with data analysis and data management and data querying. So if you want to access large amount like tables, information from tables, you want to use SQL, or if you want to do like operations with tables, like adding columns together, adding rows together, you would also use SQL. So let's kind of get straight into it and some of the syntax of it. So the most important kind of command / keyword is select and from. So the from keyword specifies another table to get data from, and the select keyword just specifies what columns we want to take. So let's say on the right hand side there was a table called foods, and from foods we want to get the name column, the weight column, and the price column. So in order to do that, we would do select name, weight, and price. So there we're selecting the column names, and then from foods, which is the table that we want to get it from. So are there any questions about that? So I'll move on. Next is where. So where is kind of like a conditional. So it's similar to like an if statement in Python. So it's like you basically are looping through all the rows of the table, and you're determining where price is greater than 10. So in this case, price is greater than 10. So if you only want to get rows in which certain conditions are met, you use the where statement. So it's basically a filter mechanism. And if you've taken data 8, I think you'd be familiar with something like this. I think they also use where data 8. So again, in this example, so we only want to look at the foods whose price is greater than 10. So again, we use select name, weight, and price because those are the column names that we want. And from foods because that's the table. But then at the end, we add where price is greater than 10 because that's the conditional we are paying attention to. And again, at the bottom in SQL, you don't have a double equal sign. The equals operator is just equals to, and then the not equals to is the exclamation point equals, or the less than or equal to and greater than equal to. The next thing is order by. So if you want to order a specific order your table by a specific column, you can do order by column name, and you can do ascending or descending. So again, if you do descending, it'll start from the highest value and go to the lowest value. And if you do descending, if you do ascending, it'll be the opposite. So I believe it defaults to ascending as well. So just looking at this example, if you want to order by weight, going from the highest weight to the lowest weight, you're going to do order by weight descending. So are there any questions about that? All good. Okay, next is limit. And limit is when we want to specify how many rows we want. And let's say we have a table with like hundreds of rows, but we only want to take 10 rows out of that. So let's say we want to take the 10 rows with the highest weight for this example. For this example, we're taking the row with the exact highest weight because we only did limit 1. But for the example I'm giving, let's say we did limit 10. So what it would do is it would find all the rows whose price is greater than 10, and then out of those rows, it would order those rows by the weight, and it would take the top 10 like names of the foods with the highest weight. So does that kind of make sense? Limit is a way of just reducing and specifying how many rows we want in our table. If there are no questions, we'll go on to the next one. Joining tables is where SQL kind of gets a little tricky and you need to be really careful. So joins are specified by multiple comma separated tables in the from clause, as well as join condition in the where clause. So what this means is we're trying to join two tables together, and oftentimes we'll try to join them together by a common row common column that they have. So in this example, we have two tables. One is the foods table. In the foods table, we have ID, name, weight, price, and type. And in the orders table, we have just name and ID. So if our goal is to match the person's name to the name of the food they bought, we would have to join them by what ID is similar. So Kevin Moy has an ID of 1 and he bought an orange. Kevin Moy also has an ID of 2 and he bought an apple. So think of the ID as like a purchase receipt, and you're joining foods and orders by that. In this case, what we would do is we would do select O.name as customer and F.name as food. From foods as F and orders as O. So what is very significant about this that you should take away is when we're doing foods as F and orders as O, we're basically saying we're going to call the foods table F and the orders table O. And then, so when I'm joining tables, I always look at the from first, because that's what we're going to be calling our tables in the specific line that we're working with. So foods will be F and orders will be O. And what we're doing is we're selecting O.name as customer. So if we go back to the table here, since orders is O, orders.name, I think. O.name. So we're taking the name column from the orders, and we're taking the name column from the food table, and we're basically merging them into a table. And we're only doing that when F.id is equal to O.id. So if we look back, we're basically only merging them if the column IDs match up. So as you can see, this would be the output of the join command. So any questions about joining tables? This one's kind of tricky. None? Okay. Next is aggregation. So this is the idea of grouping together by like terms. So if there are a bunch of rows that are, let's say, have the same name. So if Kevin Moy bought a bunch of products and you want to group all the products that Kevin Moy bought, you would group by name. So doing this, you can essentially, what's good about this is, again, basically you can just group items to get like items together. So with group by, you can also use the having keyword, and this filters our groups with conditions. So for this example, select name from orders, group by name, having count greater than 3. So when you do count of star, you're just basically counting the number of rows there are in a group. So in this case, you're selecting name from orders. That takes the order column and you're selecting all the names in that table, and you're grouping by name. So as I mentioned earlier, basically taking all the orders bought by a certain person and then you're grouping them together. So all of Kevin's orders will go together, and all of let's say whatever other names there were, all of the orders will go together. And then you're doing having count greater than 3. So that means if a certain person bought more than 3 items, then they're still in the table. So this would be the output. And since you're only selecting name, there's only going to be one column in the end result table. So if there's any questions about like aggregation, I'll put them in the chat. Moving on. This is kind of like a little cheat sheet of basic keywords that you can put on, because I think you get 3 pages to put on your final. And yeah, I'll leave this up there for like a few seconds if you guys want to copy it down. Or take a picture. So after this, let's get into some practice problems. So in this example, the scoring table has 3 columns: a player column of strings, a points column of integers, and a quarter column of integers. So the player table has 2 columns, and then the player table has 2 columns: a name column of strings and a team column of strings. So we want to make an SQL statement so that they compute the result, even if like these tables were slightly changed up a bit. So in part A, we want to complete the SQL statement below to select a 1-column table of quarters in which more than 10 points were scored. So I'm going to give you about like 3 or 4 minutes to work through this problem and give me an answer. We're gonna review the answer in about like a minute or 2. Or if you're ready, just maybe put your hand up if you're ready to see, so I can get a gauge. Okay, so let's review it. Does anyone here want to try this filling in the blanks? Anyone? Anyone in the chat? Maybe want to unmute? Okay, if not, I'll just go over the answers. So the first thing we're gonna do is we want to define the column that we want to select, and in this one it's fairly basic. It's saying that we want to get a 1-column table of quarters. So the first thing we're gonna do is do select quarters, and we also want to identify what table we're trying to what table we're trying to get our data from. So in this case, we want to look at the scoring of the teams. So we will do select quarter from scoring. And then after that, we're doing group by quarter. So what it'll do is it'll take all of the quarters together And it'll separate by first quarter, second quarter, third quarter, and fourth quarter. And I like to think of it as having subtables. So like a subtable for the first quarter, a subtable for the second quarter, and so on. So because we want to do every quarter in which the number of points scored was greater than 10, we will do having some points greater than 10. And this is because when we use group by, we want to use the having keyword instead of the where keyword. So what this statement is doing is basically every quarter whose the sum of their points is greater than 10, we'll select that and put that into our new table. So as you can see, the results were quarter 1 and quarter 4. Any questions about that? If not, I'll move on to the next one. The next part is complete the SQL statement below to select a 2-column table of the points scored by each team and assume that no players have the same name. I'm gonna give you like 3 or 4 minutes to work on this, and then we'll go over that together as well. Are we ready to go over this problem? Okay, so I'm gonna go over the solution now and kind of break it apart. So in this problem, we actually want to use both tables. So right from just like knowing that, I'm gonna do from scoring comma players. So what this means is I want to access both these players and scoring tables. And the reason I want to access the players table in this is because I want to know what team each player plays for, because in the scoring table, I'm not given that information. And also because there are no column name overlaps, I'm not going to do something like scoring as S and players as P. So I'm just going to do from scoring comma players. And within that, because the table is asking me to give me a column with one column being the team name and the other column being the sum of the points, I'm gonna make my first column team. I'm gonna go into this what's after after the first comma in a second, but first we're gonna think like, how do we make sure we can group all the players of the same team together? So I'm thinking we're gonna need something like a group by team in the players table. So I want to first join these two tables together by the player name. So I want to do where player equals name. So if we combine both tables together, I want to combine them by the player and name columns. So I'm going to do select team comma sum of points. Team comma sum of points from scoring comma players where player equals name and group by team. So what this is basically doing is we're first combining these two tables, and we're gonna combine them as it says where player equals name by the player and name table, by the player and name columns. And then what we're gonna do is we're gonna group by team, so we can get all the players who are on the same team together. And then what we're gonna do is we're gonna take the sum of the points of all of those players in their subtables. So everyone who's on Cal, we're gonna sum up their points, and everyone who's on Stanford, we're gonna sum up their points. So as you can see, this is the final output table. Any questions about that? Yeah, yeah.
Are you supposed to specify what like in the where statement, put it like, so I put players not there and scoring not there.
So in that case, in this case, because there are no overlapping column names, you don't have to do that. Because when you're joining, because when you're joining, it'll just combine, like make all combinations of the table, right? And since there are no like column name overlaps, you don't really have to specify, like, you don't have to like scoring dot or something dot, because there, yeah, as I said, there are no like name overlaps. But your solution also works. Yeah. If there are no more questions, we'll move on. Spring 2019, question 9. It's saying create a table called large spenders that contains the name and amount spent by everyone who at least spent at least $25. So this is a slightly more difficult problem, so I'll give you about 5 more minutes to look through this. Okay, you'd put in the chat or something how you're feeling about this problem and how much more time you need. Okay, so. Um. Give it another minute or so. Okay, so I'm gonna go through this now. So the first thing we want to think about is what columns do we want to look for and what tables are we trying to get our data from? So in this case, we actually want to get our data from pretty much every single one of these tables, because just by we're gonna use a products table to get the price of each product that a user buys. And we only know the sales of what user bought everything through the sales table, but the sales table doesn't give us the name of the users, and that's given by the users table. So in this case, we want to use every single one of these tables. But the thing is, as mentioned earlier, is we have column name overlaps. So both the users and sales table have both the sales and products table have something called product ID. And because of that, we want to rename our table. So we want to do something like users as U, products as P, and sales as S. So this means we're going to reference our users table as U, products table as P, and sales table as S. And we'll use dot notation to extract specific columns from those tables. So that's going to be kind of the four from line, and then the actual columns that we want to get are the name. So I can imagine we're going to do something like u.name, and we're trying to get the total amount that they spent. So let's do sum of price as the second column that we're trying to get, and I'll explain why it's sum of price a little later. So let's go through here. And as we said, users as U, products as P, and sales as S. And again, we want to match up the users with the user IDs with the proper user ID in their transactions. So we want to do something like s.user ID equals u.user ID. So we're basically matching up the users table to the sales table. And then along with that, we want to do and p.product ID is equal to s.product ID. So we want to match up everything in the products table with everything in the sales table. So that's going to be our where line. And then we also want to group the table by the user ID. So we'll do group by user ID because we're trying to get everything that a specific user bought. So we'll do group by u.user ID. And then finally, since we've grouped everything together, we want to find the total amount of products that they bought in terms of cost. So we'll do halving because we're obviously working with group tables. We'll do halving sum of price is greater than or equal to 25. So if there are any questions about this example, this was the last example, so let me know and put them in the chat. Chat. Okay, so can you explain why you used sum of price? So sum is basically an aggregation keyword, and what we're doing is, so what we've done so far is we've grouped by user ID. So we have, as I mentioned earlier, I like to think of it as subtables. So we have a subtable for everything that user ID 1 bought, and user ID is obviously Aria. We have a subtable for everything that John has bought. So having done that, what we're gonna do is we're gonna take the sum of the price in each of those subtables. Why is it not sum of p dot price? I believe because there's no repetition of the column name price, but I'm pretty sure p dot price should work as well. Is there any difference between grouping by u dot user ID and s dot user ID? I don't think so. I think it should be the same thing. And then could you explain why you say, answer that? Why not group by u dot name? Why not group by u dot name? Because in this example, actually I think grouping by u dot name would also work, I think. Yeah. So you could use p dot price is greater than. No, you wouldn't be able to use p dot price is greater than 25 because p dot price would only be referring to one row, and we want to find the entire sum of everything that like a specific user bought. So in that case, we want to sum all of the rows together. So we have to use some sort of aggregation key method. So we do sum of price is greater than equal to 25. If that clarifies it. And so yeah, you can also group by u dot user ID or s dot user ID, both work. And sum of p dot price would also work. So yeah. Any other questions?
Is there an actual large spenders table, like that you have the values on it? Or is it just more a conceptual question?
I don't think we have no, we don't have like a large spenders table. No, we don't have like I think just to imagine what it would look like, it would be like one column would be like John, Arya, Sansa, whatever, all the names, and then the column next to it would be called amount spent, and it would be how much ever money John spent, how much ever money Arya spent, and so on. So just like a two column table. Could you use amount spent in the last line? No, because that's what you're just like naming your table, like the column at the end. So I don't think you could use it. You would have to directly cite column names that are used in like the previously made tables. If there are no more other questions, that's the end of the review session. Thank you guys for coming, and good luck for your final.